welcome back. So this is a recap of the Extremely Open Science stream that we did a couple of weeks ago. So last week we didn't have a stream. We had a cyclone. Fortunately for us in Brisbane, by the time it reached us, it was an ex-cyclone, and that's actually the technical official term for what it was, or a tropical low. But it did batter the Gold Coast quite heavily. So I don't want to minimize the impact just because we didn't happen to be the ones that really got it. But there were people without power and even water for a long time. But fortunately here in the city, it was all very, very minor. So we were still at home last week when the stream normally takes place, so we didn't do that. I also couldn't come into the office and record the recap. So let's want to do a quick recap. Also, frankly, a little bit for myself to think a little bit about where we left this off and where we'll pick it up tomorrow morning or later in the evening for some of you, depending where you are in the world. Right, so what we did is we did two things. So first of all, we've been looking for a long time at the length of genes grouped by KO, by KEGG orthologous group. That worked really well. However, it does have the disadvantage that we were using an approach where basically blast against the database. It was not even a particularly well curated database, and then we took the top hit. And this is because this is the approach that CheckM2 uses, and for CheckM2's purpose, actually, this is fine. They don't need to use a very fancy method because because for them, this is just the input to another system, which is the machine learning based system, and these machine learning based systems are actually very, very robust to these errors and changes in its. So maybe let's just explore something else, and so we decided to explore using Eggnog Mapper. So we'll just, instead of running KOs, we're going to run Eggnog OG, so orthologous group. So same concept, a different database and a different implementation. I think these two together probably a good idea. Also frankly, because because KEGG only covers a part of all proteins. Eggnog only covers a part of all proteins, but it covers a larger part of all proteins. So this could be So we did two things. So we downloaded Eggnog Mapper, the database. So all of these tools, they have a database to which you're annotating your proteins, and those tend to be quite large. And so we downloaded that when we wrote the code for that. I think that's And then the other thing we did is we wrote this. So one of the things we've been doing is, we start with the genome that we got from ProGenome. So we're going to say, okay, this is the perfect gene, or at least our gold standard. And then we introduce mutations, and we do this. We introduce 25, 50, 75 mutations. And actually, the way we do it is that we introduce 25, and then we introduce an additional 25, and then an additional 25. Right. So when we predict genes from the original, and then we predict genes from the mutated versions, these are going to overlap extensively, right? There's going to be a lot of the same sequence over and over again. So in the past, we've simply ignored that fact, and we've just fed all of it into the system. Perfectly fine. Except it's very wasteful, right? Means we are computing the same thing over and over again. So we decided we should do something a little bit smarter, and so for example here we're taking, I'm just going to show you. So we take whatever this is. Actually, I don't know. I don't recognize these off the top of my head. Right. So let's go over all of the mutated files, and then we are going to rename all of the proteins. And we are going to rename them so that they have, basically, we keep a single copy from each one. And so just to give you an idea for this one example, so let's see, total sex. We could do this very quickly. And so there's, let's run that to 500,000, and when in fact only, so the 500,000, only 8,000 actually different sequences, right? Again, because we'd start with the perfect genome, and we have 25 mutations. We're not changing every single one. We're changing roughly 25, and actually, so we write them all into a single file, and we're just using a short hash, as the code for each one, and then keeping. So this is where it can get a bit tricky, so we keep these mappings. So which sequence corresponds to each. Which sequence corresponds to each code, right? So then later we can classify all of these using eggnog mapper, and then then sort of backtrack and have the result as if we had classified all of the individual sequences, right? So and so in the meanwhile, we decided, okay, since everything's still kind of running, we could also check, so if, as we increase the number of mutations, so this, let me just do the plot. So as we increase the number of mutations, we introduce new sequences, and we start missing new sequences. And actually it was interesting that for the most part, we are actually introducing more sequences than we are missing. And we are introducing more sequences than the number of mutations. Probably because, and this is maybe something to look at a little bit tomorrow, probably because we introduce sequences by breaking up two, so we have a long sequence in the real thing, and then we introduce a mutation, and now we have two short open reading frames, and so sometimes novel sequences get created. So it's not just that we create a new by being a variant, but we create two new variants, right? And right, so this is this is also, so this is what we're seeing. Obviously tomorrow, or from tomorrow, we will be able to start seeing whether these are just new sequences that still correspond effectively to the same number of orthologous groups, or whether sometimes we introduce a different orthologous group. Right. So we will see that tomorrow. We'll try to write the code that links these things together, so that we get these data sets that have a single copy for each sequence, run eggnog mapper, and then back propagate, so to get the results as if we had gotten every single variant, right? Okay, so we'll start on that tomorrow. So I'll be posting also to the mailing list, just confirming also that we're back after the cyclone. Yes, do subscribe. We've been also posting a couple other things to the channel over the next few days as well. So yeah, join us on the mailing list, and talk to you soon.